Now let's have nested class with append. With append, this means we are going to use a list. So here is our previous example: an outer class animals, an inner class mammals. 3 mammals were created, or 3 objects were created in the class animals. Each one of them calls the inner class mammals, and therefore it calls the constructor of mammals, and the attributes name and move are passed to the newly created object here in the outer class. So instead of having 3 mammals, we will just have one list called self.mammals, and this is equal to a list. We really don't need all this. Now we must have a function which adds every mammal to the list self.mammals. So let's define a function called add mammals with the arguments of the inner class. This function will add every new mammal created by calling the inner class, which is mammals, with the attributes name and move. The new mammal here instead of mammal 1, mammal 2, and mammal 3 in the previous example. Every new mammal here will be added to the list self.mammals. So we have self.mammals here. We append using .append every new mammal created. In the previous example, we already had the display animal function here just to print some data. It prints self.alive, which is the variable created in the outer class. Of course, we don't need self.mammal 1 and 2 and 3 now. We just have a list, so we can easily write print mammal.display mammals. So let's cut those, and we will use the display mammal, which is the inner class method here, displaying data about the mammals. Now we have a list of mammals called self.mammals. Let's make every element inside it be mammal. We need now to make every element which is called mammal inside this list self.mammals to call the display mammal function in the inner class. So we simply write here and take care of the intent. Mammal, our chosen name for the counter or the elements in the list, dot display mammal. Let's take it from here and have our brackets for mammal in self.mammals, the list here. Just let's have a run to make sure that everything is going okay. No errors, only living creatures is printed here because of this self-alive, animal alive, which prints living creatures here. Soon we will have other instances here. Let's call this all animals now. All animals. The instance created by calling the outer class with the outer class attribute. Before adjusting this display animal, now the created instance all animals here has the authority to call any outer class function. We will take add mammals with the attributes name and move. Let's say dog, and the move here is jump. Let's have a change. Those arguments here, or those attributes, are the arguments in the inner class mammals, which were already passed to the outer class when mammals was called. Now, before having a run now, let's have a command here, control \. Let's have our output here and have run. This means we have no errors, so we can continue. We need to display the animal function. So we write here for every element which is called mammal, in all animals dot display animal colon print mammal. Let's have a run. Living creature, this mammal has the name dog and can jump. Let's have other mammals created so we can have a copy from this and write our bat, fly, another animal, our whale, swim. And let's have another run. Living creatures, yes, this mammal has the name dog and can jump, has the name bat and can fly, has the name whale and can swim. One print for living creatures because it was really called here. Print self.alive. All animals here is the instance or class object created by calling the outer class animals, which in return calls the inner class mammals with its init function and display mammal. And note that display mammal was called here in mammal.display mammal in the return to print. Take care here. We can't say for mammal in self.mammals here, the list created, because we have no authority to use self outside the classes. So we use the object created, all animals. This concludes with the nested classes using a list.